Maybe you're a town planner working on updating your community's master plan, a municipal board member making decisions about development applications, an engineer designing a culvert, or a contractor working with a coastal homeowner on some renovations. You know that flooding and storms are already impacting communities in coastal New Hampshire, and that these issues are projected to become even bigger challenges with climate change. You may be wondering how to incorporate the latest coastal flooding science into your project. A good place to start is the New Hampshire Coastal Flood Risk Guidance, which provides a step-by-step approach for using the latest local scientific information about sea level rise, storm surge, extreme precipitation, groundwater rise, and freshwater flooding. The guidance is designed for municipal staff and volunteer board members, state agency staff, professional consultants, and coastal residents. The guidance can be applied to a wide range of projects, including planning projects like master plan updates and capital improvement plans, regulatory projects such as improving floodplain regulations, and site-specific projects, including both new construction and redevelopment or relocation of buildings, infrastructure, and other assets. Both the state wetland regulations, which protect tidal and freshwater wetland resources, and the alteration of terrain rules, which ensure large development projects adequately control and treat stormwater, now require permit applicants to consider the coastal flood risk guidance. Municipalities can also take similar approaches and reference the guidance in their own land use regulations. The guidance outlines a 7-step process for incorporating coastal flood risk in decisions. This approach is intended to be iterative. You may need to go back and forth between steps and adjust along the way. There is also a companion worksheet that guides you through the process. Let's take a look at the steps. First, identify the type of project and the time frame. For example, the planning horizon for a master plan update project might be 30 years, with incremental updates every 5 to 10 years. The useful life of a new hospital building might be over 100 years, assuming regular maintenance. Next, determine the project's tolerance for flood risk. Tolerance for flood risk means an individual's or a community's willingness to accept a higher or lower probability of flood impacts based on several project characteristics and regardless of the actual risk of flooding to the project. It's a subjective concept, so your tolerance for flood risk might be different than my own. Tolerance for flood risk may be higher or lower depending on how much you value the project, how damaged it would be if it flooded, how difficult it would be to adapt to future flood risk, and how important it is for public function or safety. For example, a project like building a new hospital or upgrading a wastewater treatment facility would likely fall into the low or very low tolerance for flood risk category. These facilities would be expensive to replace, may be difficult to modify once constructed, and play a critical role in public function and safety. As a result of their low tolerance for flood risk, these projects should plan for higher amounts of flooding that may be less likely but would cause devastating consequences if they were to occur. On the other hand, a project to build a walking trail may have a high tolerance for flood risk, considering it is relatively low cost to replace, pretty easy to modify once constructed, and not very important for public safety. These types of projects can typically plan for lower amounts of flooding. After identifying the project's tolerance for flood risk, the guidance helps you determine which sea level rise estimates to use in planning. The online New Hampshire Sea Level Rise Mapper provides maps showing depth and extent of water levels with different amounts of sea level rise. Here's an example of how the town of Newmarket incorporated sea level rise projections in a site-specific project to replace an undersized culvert where Bay Road crosses Lumberland Creek. The project team planned for 3.7 feet of sea level rise by the year 2115, which is in line with the guidance for a project with high tolerance for flood risk and approximately 100 years of useful life. The redesigned culvert, pictured here, reduces flood risk, improves aquatic organism passage, and allows for future migration of the salt marsh as sea levels rise. Next, you'll want to consider how coastal storms on top of higher sea levels may magnify flooding impacts to your project. The online New Hampshire Sea Level Rise Mapper shows how the current 100-year floodplain may expand in the future under various sea level rise scenarios. The guidance can also help you figure out the appropriate design flood elevation, or how high you should elevate your project above current flood levels in order to account for sea level rise. The City of Portsmouth recently updated its zoning ordinance to create an extended flood hazard area within which new construction is required to build to at least 2 feet above base flood elevation. This is an example of a regulatory project that provides protection against increased flood risk. We now know more about the below-ground impacts of rising seas. As sea level rises, fresh groundwater does too. Rising groundwater levels are projected to have impacts further inland than surface water flooding from sea level rise. The guidance helps determine the amount of projected groundwater rise for your particular project. Projected groundwater rise has been mapped for some coastal New Hampshire communities, and available maps can be explored on the New Hampshire Sea Level Rise Mapper. Coastal New Hampshire communities are starting to experience, study, and address issues related to rising groundwater levels. For example, the City of Portsmouth surveyed property owners in the Historic District to assess basement flooding issues associated with tidal events and heavy precipitation. The town of Durham is completing a modeling study to determine the potential impacts of rising groundwater levels on infrastructure and water quality. The study followed an approach consistent with the guidance to select the appropriate sea level rise scenarios to simulate groundwater rise and changing aquifer recharge in town. Using the model results, project partners will complete a vulnerability assessment to identify at-risk areas and critical facilities, including things like private drinking water wells and septic systems, utility infrastructure, hazardous waste and contaminated areas, and stormwater systems. In addition to sea level rise, storm surge, and groundwater rise, the guidance directs you to plan for more extreme rain events. Increasing precipitation intensity will result in greater freshwater flooding. The guidance recommends that projects plan for at least a 15% increase in extreme precipitation estimates, rather than relying on historical rates. Recently, the town of Lee undertook a modeling study to develop flood inundation maps that incorporate current and projected 100-year flood events based on future land use changes and rainfall estimates. The town is finalizing updates to its floodplain ordinance to incorporate the new maps, as well as best practices for floodplain management. The last step is to bring all of these considerations together, assess cumulative risk, and identify and evaluate adaptation options. Options can range from taking no action to relocating assets out of harm's way. For example, the town of Hampton conducted a flood mitigation analysis for 2 low-lying neighborhoods that used high-quality sea level rise and storm surge modeling to investigate alternatives to reduce future flood risks. The study evaluated options across the avoid, accommodate, resist, and relocate spectrum. For example, a recommended option in the avoid category is to evaluate zoning ordinance and site plan regulation changes in order to limit and manage expansion and growth of development in flood-prone areas. Recommended options in the accommodate category include improving drainage and restoring the marsh. Installing an earthen berm to block tidal flooding is an example of a resist strategy. And in the relocate category, a recommended option is to continue to investigate the use of managed retreat, which would remove buildings and impervious cover and restore the floodplain. Alternatives were evaluated based on their ability to reduce flooding and erosion, increase public safety, and naturalize the marsh, along with permitting feasibility and cost of implementation and maintenance. The guidance worksheet, which appears at the back of the report, helps evaluate adaptation options based on the degree to which they mitigate flood risk and meet the project goals. The guidance also outlines a set of guiding principles, which should be considered when evaluating options. These include, for example, reducing greenhouse gas emissions, considering the impacts on vulnerable populations, adopting a flexible adaptation approach, and considering the liability of not taking action. There are many ways to apply the guidance to make projects and decisions more resilient to the impacts of climate change. Planning ahead for coastal flood risks is essential to save lives and money, sustain quality of life, and protect New Hampshire's coastal resources. The best way to learn how to use the guidance is to take an example project and walk through the step-by-step process. Our team is available to help you do that. Find the guidance document, additional resources, and contact information for assistance at the link in the video description. This video was funded in part by the National Oceanic and Atmospheric Administration, Office for Coastal Management, under the Coastal Zone Management Act in conjunction with the New Hampshire Department of Environmental Services Coastal Program.